Okay, so this is the next video on working with annuities and the TVM worksheet on the TI business calculator. And in this video, we're going to be talking about how to do annuities due, which is the assumption that the payments occur at the beginning of each period, not at the end. And in order to achieve that in the most efficient way, the TI calculator has a setting called BGN. And first thing we're going to do is show how to set that setting. So let's go ahead and do that. So there's a BGN, and here's where it is. If you look at the calculator, it's right here above the payment. So I have to use the second button to get it. And here's what we're going to click out. We're going to click second BGN. And currently it's showing end of period payments. So to change that, you have to say second set, which is over the enter key. And that changed it to BGN. And now to get out of this menu, you say second quit. So second BGN, second set, second quit. And now you can notice that the calculator has a little BGN symbol. That's supposed to remind you that you have set the BGN. And from this point on, if you're going to use this setting, which it's very convenient, so I don't recommend avoiding it, you have to remember when you've set it. You have to be sensitive to that symbol up there. And don't go do the next problem, which turns out to be an annuity immediate. And with that setting up there, you'll get the wrong answer. Okay, so anyway, we have annuity due now with BGN. And I want to show you how that changes the TVM equation. So the calculator's display will show a small BGN. That's a reminder that you have that set. To unset BGN, you would do the exact same button sequence, and that would change it back to end of period payments. So when BGN is set, here's how the TVM equation changes. It looks exactly the same as in the previous video. The only thing here is that the annuity symbol now becomes the double dot annuity, which means beginning of period payments. That's it. And if you multiply by the growth factor power, you get the equation with the accumulated value annuity symbol S double dot. And so again, that assumes beginning of period payments. So let's do one quick example here. Basic annuity problem. Calculate 100 times the annuity due, A double dot, for 8 payments at 4%. And we did this for the annuity immediate in the previous video, so I'll just go through. We're going to put in 8 for N, 4 for the interest rate, and present value we'll leave alone. The payment is 100, and the future value is 0. So we've got all that. And now all we have to do is say compute, hit the compute button, present value, and there's the answer, $700.21 if you're rounding. So that's it. That's how to calculate an annuity symbol. If you're doing, I won't do it here, but if I wanted S double dots, you do the same thing we did in the previous video. You'd hit 0 for present value and compute future value, and that would give you $958.28. That's the accumulated value of that annuity at the end of the annuity. Okay, so let's do a problem now. Okay, here's an annuity due makes 10 payments of $20 every other year with the first payment beginning immediately. So the beginning immediately tells us this is, and the annuity due tells us the beginning of period payments. The nominal annual interest rate compounded semi-annually is 6%. Calculate the present value of the annuity. So first I'll review we did this one in the class note slides, but I'll review the timeline of the payments here. It's always worth doing when it's somewhat complicated like this. There it is. So the 20 appear every other year. So at time 0, time 2, time 4, and you get to the 10th one at time 18, not at 20, at the beginning of that last 2-year period. Okay, so the present value of that annuity is going to be 20 is the payment, A double dot, there are 10 payments, and then there's an interest rate J, where J is the effective interest for a 2-year period. And that is not given in the problem. We're going to have to do an interest conversion because they give you the nominal rate compounded semi-annually. So you do have to think a little bit, what's the 2-year rate given that the nominal semi-annual rate is 6%? And here's how that interest rate conversion works. All right, so 6% nominal semi-annual means for each half year, it's 6% divided by 2, or 0.06 divided by 2, or 0.03. But how many half years are in a 2-year period? And the answer to that is 4. 4 times a half year is 2 years. So we have to raise that to the 4th power and then subtract 1. So if I were doing this, I would go, let me go back out. Let me clear the TVM and clear that. And let's go to 1.03. So that, sorry, plus 1. 1.03 is the growth factor for a half year. Raise that to 4. And we get 1.12551. And to get the actual interest rate, we subtract 1. We multiply by 100. And there it is, 12.55088%. And I'm immediately going to set that as the interest per period. I over Y is equal to that. Okay, now how do I do the rest of the problem? Now they have the interest rate. That's almost always one of the harder parts, is doing the interest conversion. So we've set BGN already. I don't have to do that again. And now I'm going to put in 10 payments. Oops. And that goes in for N. The interest rate we've already set. You can see it if you say recall interest rate. There it is. And the payment is going to be 20. And we'll put that in with a negative sign. The future value will be 0. And now all I have to do to figure out the answer is say compute present value. And there it is, $124.37. And remember, you have to check that you have BGN set. If I didn't have BGN set, this number would turn out different and would be the annuity immediate, not the annuity due. So that's how that one worked out. Okay, and anyway, so that's a fairly simple one. The hardest part was doing the interest conversion. You have to be careful to read the interest conditions carefully and convert to the right interest per period. The interest rate you put in here has to be the interest per payment period. All right, there we go. If I want the accumulated value, I would put in 0 for present value and then compute future value. And that is what we get. So that would be with an S there, S double dot 10 at that interest rate. And you don't even have to do the first 3 buttons. All we had to do is change present value to 0 and compute future value. And we get 405.70. So anyway, that's that problem. Let's do one more problem. So Leonard has inherited a perpetuity due with annual payments of $20,000. He immediately exchanged the perpetuity for a 30-year annuity due. So instead of taking payments forever, he wanted payments just for 30 years. He might anticipate that he doesn't live beyond 30 years. The annuity makes annual payments of X. The present values are based on an annual effective interest rate of 9% for the first 8 years and 11% after that. So there's an interest rate change at 8 years. And the question is, what is the new payment of the 30-year annuity? So this is a complicated problem, and we did this in the class notes, and I'm not going to go through the derivation of it, but we found out a formula for this is x equal to 20,000 times this fraction, which is the accumulated value over 8 years at 9%, paying at the beginning. So the perpetuity due tells you that the payments are at the beginning of each payment period. And then down below you divide by the same accumulated value, S double dot for 8 years at 9%, plus the present value, A double dots, for the remaining 22 years at 11%. And that is the formula. And now the question is just how do we calculate this? So I'm going to clear the TVM. This is kind of a complicated calculation. We already have BGN set, so I don't have to do that. And what our strategy is going to be, if you think about it, I'm going to calculate each of these annuities and store them and then assemble them into the final answer. So let's see how that works. So first we have to calculate, well, we set BGN already. And now we're going to calculate the S double dot. So we're going to put in 8 for N, 9 for interest rate. So it's an annual effective interest rate, so no interest conversion necessary. 0 for present value. And we're not going to put in a coefficient yet, so the coefficient is 1. So we put in 1 with a minus sign for payment. And then all I have to do is say compute future value. And it's 12.02. And now to use it later, we're going to say store in memory location 1. So that's now in memory location 1. All right, we're going to continue and do this with the A double dot. So for A double dot, we change it to 22 for N, 11 for the interest rate. And now this time we want a present value, so we say 0 for the future value. And we have the payment already in there as -1. So all I have to do is hit compute present value. And there it is, 9.07507, and I'm going to store that in memory location 2. All right, so you should have both annuities now in the memory locations. And the rest of this is just to use algebra. So I'll show you how you come up with the final answer. We're going to add the first two terms on the top here, and that's going to be recall 1 plus the 1.11 over 0.11, which is the remaining perpetuity. So we're going to put parenthesis 1.11 divided by 0.11, close parenthesis. So that turns out to be about 10. And then we have to say equal. So the numerator here turned out to be around 22. And now we have to divide by the denominator. So I'm going to say divide by, and I have to use parentheses again. So I start that out. I recall 1 plus recall 2, close parenthesis. So that's the sum of the two terms in the denominator. And we still have to say equals to get the division. That turns out to be 1.04815. And the final thing I have to do is multiply by 20,000. So I say times 20,000. And there you go. And that's our final answer, 20,963. So when he gets the 30-year annuity, the payment raises by roughly $1,000 to $20,963.06. And that is the conversion of the perpetuity into an annuity. And it's kind of complicated. You really need to master using store and recall, but there's a lot of memory. You have to, sometimes I write on paper what's in which memory, number 1, number 2, etc., like that. So anyway, that's how that works out. All right, that's it for annuities due and setting the BGN. And I'll see you at the next calculator video.